right? But today we're going to talk about physiography, geography, and climate of Latin America. Essentially, we're going to be dealing with physical aspects of Latin America, and much of it is producing changes in the climate. So we're going to go over climate too. This is lecture number 3 from the series, and it's as we see here in the map, we're coming from the north all the way to the south. This is not really a map. It happens to be an image produced by satellite composition. It's not really possible to get a full image like this. Obviously, it's possible to produce a map, but in this one, we're combining satellite images in a very nice way, showing all the different features, like the Andes in here, all the way south. Let's see here the delta of the Amazon River, another delta over here from the La Plata River, the deep ocean happen to be close to the trench in the Chile trench, and let's see. Obviously, we see here Florida, all the Greater Antilles, the Lesser Antilles, Mexico, Gulf of Mexico, Yucatan. All those things are extremely well represented in this image. And so we're going to go into that right away. Latin America is a land having superlative features. We do have the longest and a second highest mountain range, the Andes. So yeah. We have the most active volcanoes in the planet, the biggest river in the world, the driest desert. We do have also an incredibly extensive rainforest, the largest one in the planet, and happy to be one of the most diverse places in the planet for many different species. We do have also a great reserve of potential agricultural land. Sometimes these two things are opposed to each other. Obviously, we're going to keep the rainforest, and we're going to develop the agricultural of the land. Over those two things have to be somewhat compromised. But Latin America is also a place where we have a larger reserve of minerals and energetic minerals. We're going to go over the whole class. So here, the contrast in Latin America is rather remarkable, and we see here normally our thinking about Latin America is a tropical beach with palm trees and such, but in fact, no, far away from the tropics, we go into the south area, which is about 55 latitude south, and we do find this characteristic landscape. We see here permanent ice in the continent, continental glaciers going into the sea, and both of the coastal areas, Atlantic and Pacific, are also places where we find plenty of these characteristic penguins of the southern hemisphere. There are not really any place in the northern hemisphere where penguins are living. And they are characteristic of places where the temperature is cold, at least in the water. So we're going to talk about all this. We see the Andes in the high elevation, places where we see places where all cultures were producing incredible manifestations of that. You see here the Machu Picchu city. It was, for a reason we don't really understand, it was abandoned, and then later discovered fairly recently in the early part of the 19th century, in the 20th century, and find out the preservation was quite good. So one of the highest peaks in Mexico, Pico de Orizaba, is a volcano. It's a volcano of about 5,654 meters. And it happened to be one of the places where we have an accumulation of ice. It happened to be minor in a way because, you know, the ice in tropical latitudes are not really lasting only in elevation. So the extension of these fields is rather small, but we're going to talk about that when the time comes. The highest peaks out of the Himalayas is the Aconcagua. Aconcagua is a place, it happens to be in between, right in the border between Argentina and Chile, and it happens to reach about close to 7,000 meters. Well, here we see an alumni, two alumni from UT Dallas in 2008. They actually went all the way up into the Aconcagua, which is not too difficult to do, obviously. There are different ways to access. Some of the ways are extremely difficult. This is one of the easy ways, just the route in here, going walking. Obviously, in high elevation, walking is not something easy. So you can go all the way up following the road. It's the easiest one, and the other one is much more difficult and only for very expert analysts. So the Aconcagua normal road. The driest desert happens to be also in South America, in Latin America. This is in Chile, in the north part of Chile, in the coastal area, where it's almost never raining. In fact, we see here the landscape is completely devoid of any vegetation. And then, not far from there, in fact, if we cross over the Andes into the central part of South America, is the largest rainforest in the planet, and also the largest river. This is a place where it rains every day in an incredible amount. So it's a very, very large river, the largest river in volume, and also the longest river if we count all the tributaries that form the Amazon River. In fact, most of Latin America is in between the tropics, 23 degrees north, Tropic of Cancer, 23 degrees 0.5 south, or Tropic of Capricorn. So in between those lines, you see the tropical area. So the zero latitude equatorial line happens to be in the middle. And characteristic of the tropics, we obviously know, is not much changes during the seasons. Essentially, the seasons are defined by the variation in rainfall during the year. So we have a rainy season and a dry season, and that's it. There's not really winter and summer as we normally see in temperate areas. So what we have here in this map is really full of information, but we're going to try to clarify a few. Is the regime of temperatures and precipitation in different places. And we see here in Dallas, it's a little underlined. You see Dallas in Texas, we have here maximum temperature, and the average temperature happens to be defined by these lines, and that happens in July and August, maximum temperatures. Precipitation happens to be majority about this April and May is the time where we have a major precipitation. So it's not typical of a temperate region. But in the northern hemisphere, obviously, we see another temperate region, but now in the southern hemisphere, we can go quite well to this place in here, Buenos Aires, the capital of Argentina. We see here the curves from Dallas are inverse because winters happen to be there and during the July-June period. So we see here the minimum temperature happens when we have the maximum temperature here. So maximum temperature, minimum temperature here is obviously the reason why seasons happens. But as we go into the tropical area, which happens to be about these two lines in here, we see the variation in temperature is not really much. So there's not really clear-cut seasonality. You don't see difference between winter and summer much in temperature. What we do see, and this is quite interesting, is a large precipitation time. See, this one in here is coming from Managua, I think. But anyway, precipitation is quite high during the rainy season, and that's the temperature question. So that's characteristic of tropical climates. And see here in this animation is something provided by the University of Oregon, and see the variation in temperature during the year. We go from January, February, March, April, right here, all the way into August. And we see the temperature, maximum temperature, are migrating towards the south as we go to the later part of the year. So December, November, December happen to be summer in the southern hemisphere and winter in the northern hemisphere. And it goes in that way all year long. Let's see. Same thing happens with precipitation. Precipitation is also interestingly affected by the seasons. In fact, this line in here, we see the maximum precipitation moves up and down with the summer. So during summer, see, this is September, October, November, the summer in the south, the rain is coming to the south too. And when the summer goes to the north, it's moving with it too. This line here, we're going to talk about it later. It's called the intertropical convergence zone. And it happens to be quite important, intertropical convergence zone. And it's a line where we have the maximum precipitation produced by the convergence of two important convection cells. This one here and this one here. This convection cells is called the Hadley cell. Oops. Hadley cell in the north and Hadley cell in the south. And when they encounter each other, they produce an increase in elevation with the consequent precipitation of the humid air, and that's the reason why it rains so much. The other factor changing the climate other than latitude is altitude, elevation. So what we see here in the tropics is going from the sea level here all the way to the maximum elevation achieved in the mountains, and we see climates defined by elevation. In fact, they receive these names, which are obviously you realize they are in Spanish, but these names are used in any language. Tierra Caliente happens to be defined between sea level and 3,000 feet or 900 meters. And as we go into the next 900 meters, 8,800 meters, we go into something called Tierra Templada or warm land. Then from 1,800 meters to 3,600 meters, we call something called Tierra Fría or cold land. And as we see here, we can achieve different climates depending on how high we are into the mountain. And that defines also not just temperature, also what kind of crops can be raised in those different places. So this is something is well known by the inhabitants of tropical countries, where they tend to live in places where the temperature is much more pleasant to live. So we see most of the capitals in the tropical region, which is marked by these two lines, are they tend to live in high places. Because we see here the capital of Colombia is Bogota, the capital, well, at least one of the important cities in Ecuador is Cuenca, Ambato, and places like that. So they tend to be high. Also, Mexico, not far from the line in here, is in quite high elevation. So the line between 0 and 500 meters is defined here by this particular color. We see all this is essentially most of South America and the eastern part of North America too is between those levels. So it's what we call Tierra Caliente, but that Tierra Caliente is only properly used in this area here. Don't use Tierra Caliente for this area, neither for this area here. That represents a different configuration because the seasons are very important in this and in this too. So the Tierra Caliente hot land is below 900 meters, and there we have very high temperatures during the day and during the night, and not really much variation. The agriculture is essentially devoted to tropical plants, like sugarcane, bananas, and such. If we keep going up now, Tierra Templada is this limit in here between 1,000 between 900 meters and 1800 meters. These are the days are quite warm, but during the night the temperature drops considerably. It's a place where people prefer to live. So the agricultural products here are essentially coffee, maize, vegetables, flowers, such. You see here the coloring here is defined by this highest tone of blue. All these areas in here are big part of Mexico too. Here. And then Tierra Fria is in excess of 2,000 meters. So it's quite common in the central part of the Andes in here, where we have the Altiplano in Bolivia and Peru. The warm days, cold nights, very cold nights, I should say, may actually freeze in places. The crops can be raised, and there are wheat, barley, maize, and tubers. And this is a place where the potato was essentially being originated. The potato is actually coming from Bolivia, another place where was originated. This is a proper place in temperature to be raised. And the Tierra Helada, frozen land, is in excess of 3,600 meters. So the highest mountain peaks are very cold almost all the time. The only thing that can be raised in there are highland grains, some tubers, potatoes, they can receive in places. Llamas are adapted, alpacas are adapted. In fact, they are very well adapted with that particular wool. They can be very well isolated to the cold, from the cold. And on top of that, not really very many places in excess of 4,600 meters, only the highest peaks, there's not really anything growing in here, just a few shrubs, grass, and that's it. Páramos, and this graphic is quite interesting because we see here, this is 30 degrees north, 30 degrees south, 60 south, south pole, north pole, and we see here a line. This line is very important. It's representing the snow line. Meaning what? Meaning if we do have something that goes over this line, we can have permanent ice. So just a few places in Central America, just in Mexico, we see some. And then in Central America, we see nothing. So none of these high peaks go over. So no permanent ice in those levels. And as we go further south, we see more and more, obviously. And we see 30 degrees, there are many different peaks that go up. As we go into latitude 40, 50, we see Patagonia being a place where we have an incredible amount of ice accumulated in something can be well considered continental ice. And then obviously Antarctica, the major reservoir of ice, happens to be well over the snow line. There's not really any more significance of that line farther south. So Latin America and the Caribbean can be divided into three different topographic zones according to the elevation. See, less than 500 meters, the proper name obviously lowlands, and then highlands between 500 and 2,000 meters, plateaus. It's a proper name. Plateaus are highland elevation normally topped by a flat sea. And then mountains over 2,000 meters. If you have difficulty thinking in meters, just multiply by 3 to make a rough conversion into feet. Well, here in this illustration, we see the plateaus, highlands. We see here Guyana, the highlands of Brazil, and then Patagonia in the south, the Altiplano, which is a particular category in itself. and the Mexican Central Plateau. And then lowlands, obviously, we see here in blue, all these areas are plains, lowlands where rivers are running. So we see the Amazon running here, the Orinoco running through here, the Uruguay, Paraguay, and some like that getting together in the De La Plata River down there. The funny thing about it is most of the rivers are running towards the Atlantic. So we're going to talk a little about that later. The Andes are really one of the most conspicuous features in South America. The Andes can be divided in 3 different places: North, Central Andes, and Southern Andes. From the north, we can actually start in Venezuela, going west, and getting together with 2 other branches coming from Colombia, and then joining one in one series of peaks that is making Central Andes before making the Altiplano, and then all the way to the south when finally goes into the ocean. So in the north we see Venezuela, Colombia, and Ecuador, and the central part Ecuador, Peru, and Bolivia, high altitude plateaus, also properly used. We should use the term altiplano because it's actually more than a plateau. It may be in the same level that the Tibetan plateau, which is quite high too. In the southern part of the Andes is essentially the border between Chile and Peru. In fact, it was defined as such. The area where the mountains are dividing the waters is the border between the 2 countries. The elevation south to Santiago is going lower. You can see kind of that particular form in here, the Andes. So here, if we make a cut to this point in here, we see the plains, and then the 3 branches of the Andes, 1 and 2 and 3. And finally, the one that go farther north is the one in Venezuela. And then we go into the Altiplano here, we see high elevation here, another high elevation here, and in between something quite flat. That's the Altiplano, Bolivian, Peru Altiplano. And as we're going to the highest point in about this latitude, Santiago here, more or less about 43 degrees south, we see the highest peak in this point. And then the plains. This is the coastal plain in Chile. It's quite short, in fact. And as we go further south, and we make a cross section here, you're going to see a high elevation here, but no higher as it is in the central part. So, this is something we call a topographic profile. Profile is essentially we were able to cut through here. Let me just change my highlight. If we cut through here with something like a knife and put it on the side, we'll see something like this. So that's a topographic profile. In general, we see an exaggeration in the vertical to emphasize the mountains. Now, all in all, what we see in South America is the lowlands, the Amazon lowlands, the Orinoco lowlands in here, and the Paraná, Paraguay lowlands, essentially going all the way into the Pampas in the south. And then we have the plateaus, which are higher, but kind of flat. The Brazilian plateau, the Guyana highlands or plateau, and then the Patagonia plateau. In Mexico and Central America, we do have also another plateau, the Mexican plateau. And further south, we do have a volcanic arc in Central America. The Mexican plateau is lower than 4,000 feet. So between 1,000 to 1,500 meters. it goes from Juarez all the way to the south in the near Mexico City. That's essentially the plateau. It's a region very rich in mineral deposits, particularly silver, copper, zinc, and some other important metallic minerals. In the Central America, essentially the highlands are formed by volcanic chains. It goes from the Tehuantepec Isthmus to Costa Rica and Panama. So we're gonna see those in the map. That's essentially what it is. The Northern Plateau from Juarez, in fact, all the way to the Mexico City and the Central Plateau. And then we have the two sierras, Madre Oriental or Eastern Sierra Madre, or the Occidental or Western Sierra Madre in the two sides of the plateau. And then the highlands in here produced by volcanic action is essentially the beginning of Central America. The limit of North America and Central America is essentially through this area here called the Tehuantepec Isthmus. Talk a little more about it. So Middle America, we like to call it, Mexico to Tehuantepec. It's a system of that goes all the way from the north. In fact, it's related to the Rockies, and go to the Tehuantepec Isthmus right here, defining a different context. All these can actually be considered North America as a continental crust, part of North America, and the island arc situation here is the rest of Central America. Tehuantepec, which is this one in here, to Panama, is essentially highlands produced by volcanic origin with very high plateaus in places like we can see here. Not very high plateaus, but they're actually containing lakes in areas which are rather interesting from the point of view of geothermal energy. Later we're going to talk about, since we have volcanoes and water, that's actually a good combination to produce geothermal resources. Now, what is Central America? This is something that's not really a good consensus about the definition of it. Central America in English is considered a region of the North American continent. 7 countries: Belize, Guatemala, El Salvador, Honduras, Nicaragua, Costa Rica, and Panama. Mexico, completely or in part, can actually be part of Central America or the North America. In Latin America, Spain, Iberia in general, and some European countries, the Americas are considered to be one continent, in fact, just one. And Central America is a region of the continent. In the UN, United Nations, Geoscience, they define the region as of all the states of North America, south state of countries, south of the United States. The European Union is excluding Belize and Mexico from this definition of the region. And it does sense from the geological point of view, really does. Why so? Well, because we see here Belize is over here, this area. This is Belize, a tiny place in here. And then Mexico. So the whole thing is north of the Tehuantepec Isthmus. And that is essentially the North American continent. So Central America, geologically, much better defined as this part. So, anyways, after we clarify this, we go a little over the situation in geological terms, in tectonic terms, I should say. So, right here we see Yucatan, the area of Yucatan, Belize happens to be right here, and then a detail of this is represented in this larger frame. So what we see here is the 2 major faults. The Potochic fault and the Motagua fault are really the active element here, those are transforming faults, separating the two different units. So this plate is part of the Caribbean plate, this part of the North American plate. So geologically, we see a clear distinction, and it's what we're going to be following here. If you happen to be interested in reading some more about this, follow the link here. Is a paper about the geologic boundaries between North American plate, and Central American, in fact, the Caribbean plate, because the whole thing is a unit. Caribbean plate goes like this on the way, and this is the subduction zone here, and we do have another subduction here. So it's an interesting, very active plate, the Caribbean. Anyway, but right here we have a video. It's a little old. In the beginning, when we started with this course about 20 years ago, it was quite the novelty. Well, now we're going to see here is a flyover produced by computer animation of images coming from the shuttle, and you can tell this is an old resource of NASA. Hope you can enjoy it and see it.
This computer animation uses elevation data from the Shuttle Radar Topography mission and an image mosaic from the MODIS satellite to simulate a high-altitude flight along the Andes Mountains and the Pacific coast of South America. We have just descended over the Straits of Magellan and are now flying northward over the glaciers and fjords of Patagonia. Along the southern Andes, the western slopes are wet and vegetated, and the areas to the east are dry as the mountains capture moisture carried by winds from the west off the Pacific Ocean. But as we head north, the prevailing winds are instead from the southeast, and the pattern reverses. Here, along the Pacific coast, the Atacama Desert is one of the driest places on Earth. Here, too, the Andes Mountains widen and are capped by the Altiplano, a broad highlands that hosts lakes from the dried and brown to the deep and blue, of which Lake Titicaca is the most prominent. As we enter Peru, the mountains narrow and form a linear boundary between the Pacific coast on the west and the lush green Amazon basin to the east. Over the centuries, there has been little interaction between native peoples of the high Andes, where the air is thin and dry, and the adjacent low-lying Amazon jungle, where the air is heavy and humid. Even today, few roads descend the intervening mountain slope. Turning our view northward and crossing the equator, we see the mountains branching and extending northeastward toward the Caribbean Sea. Winds from the Caribbean blow nearly parallel to the mountain trend instead of across the trend, and the rain is distributed more evenly. Rain-shadow deserts, like those we have seen further south, do not occur here. We end our flight high above the Isthmus of Panama.
Now, talking about the plateaus in South America, we see very important features here, in particular the Brazilian plateau. Brazilian plateau is the highest place in Brazil. Brazil doesn't really have any active orogenic place other than these coastal plateaus. So they're very important natural resources, minerals for Brazil. They do have an incredibly large reserve of iron ore, many different kinds of minerals. Even they can actually mine diamonds in Brazil. So it's coming from the southern edge of the Amazon basin all the way to the La Plata River. The major population centers of Brazil are very much close to this plateau in the coastal area. So they do have an elevation close to the shore, and it's making for a very interesting landscape, as you can see in the postcards from Rio, where you see a very large mountain right by the sea, where they have a famous representation of Christ on top of the mountain. Following in that, the Guyana Plateau is quite similar, but it's in a place where it's not really many inhabitants living there. So it's a jungle area with an elevation over the plains, quite remarkable, because in the top of the plateaus, we do have a unique ecosystem. So somewhere we're going to talk about it. The Patagonian Plateau, which is in the one left, is in the south. It's very dry, and it's essentially flat full of dry grass and not really much more than that. So, yeah, a representation of the whole thing. Brazilian Plateau, Guyana Highlands, and the Patagonian Plateau here, which is lower than the normal plateau, but well, anyway. Now we're gonna go into the lowlands. It happens to coincide, obviously, because it's lower with the places where rivers are running. It's very large. Most of the area of South America is in these places. Let's see here. You see, the Amazon lowland goes all the way here. Yeah, and the Rio de la Plata lowlands is also all the way here. So very large part of South America devoted by these lowlands. So the rivers of Latin America are most of them in South America. See here, the major one, Amazon River. Most of the continent actually should come all the way here because these rivers also contribute to the final Amazon Delta list. And this one in here is the Paraná, Paraguay, de la Plata River. Orinoco River is here. And just a few, this one in here and this one in here are independent of those two major basins. And you can tell, there's not really much going into the Pacific. So the Amazon River goes almost all the way to the Pacific. So as we see here, the divide line, the continental divide that we like to call it, because it defines where the water goes in our continent. Here we see this line here representing the divide. Means any water that falls in this area here goes to the Atlantic. Any water that goes in here, raining or such, goes to the Pacific. Well, now in South America, the divide is this red line here. So almost all the water goes to the Atlantic, and some short, small rivers go to the Pacific, coming from the mountains. So that's something to keep in mind. Now, this map is representing, this animation is representing the runoff water, meaning the excess of water that is not really absorbed. Water that runs, collect into rivers and creeks, and eventually reach in the ocean. So what we see here is a majority of excess of water during the months of summer. You see, November, December, January, and then goes up north. So we see here the majority of water is in summer precipitation. So then it moves to the north into the Orinoco River and back south into the Amazon River and such. It's not just in the Amazon or in the South America basin. It happens in Africa in a big way. It happens also in Southeast Asia here. See, these are essentially what we call the monsoon rains. So we have two things in here, the tropical region, and also we have a very large area where we have mountains. And that conjunction with two factors is producing a place where we have one of the major diversity in the planet. Mountains are actually a reason why the number of different species increase. And also tropical climate is a place where we have more different species. So the two things together are making that these mountain regions happen to be extremely diverse. So the tropical South America is one of the places where the highest degree of biodiversity in the planet. No, natural resources, we're going to spend a lot of time talking about natural resources. We do have minerals, hydrocarbons like gas and oil in South America and Mexico. We do have plenty of copper. Chile is the major producer of copper in the planet. Silver still, Mexico and Peru are the major producers of silver. Brazil producing iron. The good quality iron coming from the banded iron formation from the hill plants. But it's something we're gonna talk quite more extensively in the proper chart. So I'm gonna leave it here, and then you're gonna start with a little more background in geology. Dr. Stern is gonna talk about plate tectonics in 2 chapters, and then we go into the most interesting of these elements you happen to be massive resources or reserves. And talk about the use of metals in Latin America before the Western culture arrived. And so that's something quite interesting I'm going to talk about. All right, thank you.